Here's the demo for our project, Advanced Deep Learning for Medical Imaging, Pneumonia Prediction, and COVID-19 Detection.
Due to the extended runtime of our model, we are unable to provide a complete live demonstration, as training and testing the model over 10 epochs through our datasets can take about 2.5 hours. When the model is run on a server, it takes about 10 minutes. In the future, we hope to deploy this script on a more powerful server, which will enable us to achieve faster results. Nonetheless, we will explain the implementation and final results of our model.
So our code base is split into different. I'll be highlighting the most. Firstly, we have the dataset.py file that loads in our images and organizes them based on the respective label. Our hyperparameters.json file defines the hyperparameters that we are applying to the model, such as the number of hidden layers, types of activation functions, the batch size, and etc. Inside the deep learning.py file is where we are training the model and compiling all of the ones. Then we have the train.py file, which are our most important module, as it is where our model building occurs. Finally, inside the config.yaml file is where we define which dataset we want to use, which feature extraction model, the split type, and which directory we are saving to.
Here are the results from pneumonia dataset. First, we have an accuracy of 0.94, which means that 94% of the predictions made by our model were correct. Accuracy gives us a general sense of how well the model is performing, but it doesn't tell the whole story. Next, we have the F1 score, which is 0.96. The F1 score is a balance between precision and recall. It's particularly useful when we want to ensure that both false positives and false negatives are minimized. A high F1 score indicates that our model is performing well in both of these aspects. Precision, which is 0.95, tells us about the accuracy of the positive predictions made by the model. In other words, 95% of the instances that our model predicted as pneumonia were actually pneumonia. High precision is crucial for minimizing false positives, which is important in medical diagnosis to avoid unnecessary treatments. Recall, on the other hand, is 0.97, indicating that 97% of actual pneumonia cases are correctly identified by our model. High recall is essential to catch as many true cases as possible, ensuring timely medical intervention for those infected. Overall, these results show that our model is highly effective at diagnosing pneumonia, with excellent performance across all key metrics. This level of accuracy, precision, and recall means that our model can be a reliable tool for supporting healthcare professionals in identifying pneumonia cases, ultimately improving patient outcomes.
And here are the results for our COVID-19 dataset. Our model achieved an accuracy of 0.90, meaning that 90% of the predictions it made were correct. The F1 score is 0.91, which balances precision and recall. Precision is 0.89, indicating that 89% of the instances predicted as COVID-19 were actually COVID-19 cases. And then recall stands at 0.94, showing that 94% of actual COVID-19 cases were correctly identified by our model. These results indicate that our model performs very well in identifying COVID-19 cases, with strong accuracy, F1 score, precision, and recall. This performance level demonstrates the model's potential to be a valuable tool in the healthcare sector, helping to diagnose COVID-19 efficiently and accurately, thereby supporting better patient outcomes. And that's it.
So here is going to be the demo for our script. This is what we're going to be using to run it. Here we're going into the config we're seeing the data path that we're going to be using. And then over here, the hyperparameters that we're going to be using to run this model. And here's the train.py. So we're going to go ahead and run this, but we're going to cut it the whole process because it takes about 3 hours. It has just finished training and testing. Now it's outputting all the results, which we can see on the console. Now we're going to go ahead and look at those results inside the log.txt file. And as you can see, the results were printed and they're being displayed here. These are the results that we mainly focused on, which was our mean results because we felt it was the best representation of our results.